Today we are going to present our assignment 1 on feature selection. Without further ado, let me introduce myself. And my name is Nurul Hanis, and my group members are Afiq Kushari and Akmal Arif. So let's start with the introduction. So the first one, we actually aim to study the loan data to determine the factors that can affect the loan eligibility. And next one is going to be EDA, where they analyze and visualize the loan data to gain insight into relationship between variables, identify trends, and detect outliers. And then the next one is the feature selection. As we can see, there are a few feature selection here. And modeling, where they build a predictive model that can accurately classify loan applicants as eligible or not based on the features. And the deployment will implement a web application in this assignment. So for the data set, we're using loan data set, where it contains the information of the borrowers and loans granted by a financial institution. So as we can see here, there are features on the columns. So here's the image of the loan data, and they have the loan ID with the unique identifier for each loan, their gender, their marital status, and dependence of the borrower that they have, and their education level, their employment status, applicant and co-applicant income, loan amount, the amount of loan, and the term in months for the loan, and their credit history. It's either they have a history of they have a credit history or not, and property area, like which is the whether it's urban, rural, or semi-urban, and the loan status.
Assalamualaikum warahmatullahi wabarakatuh. I'm Akmal Arif here, 2017151. And now I'll get on with the exploratory data analysis, or in short, EDA. So now that we've known about our data, let's get a little bit of insight of what EDA is. It is basically an important step in any data science/machine learning project, as it helps to understand and explore the data before applying machine learning models. EDA basically involves visualizing, analyzing the data to basically verify patterns or relationships between features of the data set. So by doing so, we can help in detecting outliers, missing values, or any biases in the data, which can inform the selection of appropriate machine learning models, and basically improving the predictions. Different data set may require different ways of doing EDA. So yeah, next up, let's get on to doing EDA on our data set. Okay, hold up. So yeah, this is our code for our assignment. First up, we import the necessary libraries, which is pandas, and then we name it as PD and also numpy s and p. These two libraries are just to load in the data, and then numpy is for mathematical calculations. So first up, as you can see right here, we just enter in the pd.read underscore CSV, which stands for comma value file, and then the file name, which is loan data, and then we just print the head of the data frame just to get a sneak peek of what our data is like. So next we just check out the data types. As you can see right here, tells you if it's an integer, a float, or something else. And on this cell right here, we just print out the unique values of a column that has categorical data. As you can see right here, property area has three category: urban, rural, semi-urban, and the dependence column has, yeah, as you can see right there, 0, 1, 2, 3 plus. The one below that, the next line, the drop loan ID. This is because, like, from a quick thought of looking at the data set, we can know that loan ID is not necessary for our prediction because it won't be having any influence on the modeling. I mean, for the prediction. And since we're building an artificial neural network, what we have to do, like, since ANN requires numerical data, so the way we handle that is we convert string values into integers. As you can see right here, maybe we check out on the gender. First up, in the first place, they were male and female, so we convert that into 0 and 1, and we do that respectively to other columns as well. And finally, we check out the data frame, and voila. As you can see right here, the gender change from male or female to 0 and 1. Next up, we're gonna drop the null values. Basically here, what I meant is that we are using the is null to check any columns that has missing values, and then we use the drop NA function to drop the missing values from the data set. So as you can see right here, before dropping those missing values, we got quite a few of columns with null values here, and then we drop, and then this is after dropping them. So now we're good to go. We got no missing values, and the data set is pretty much complete. And finally, the code uses Seaborn and Matplot library to visualize the correlation of the features of the dataset using a heatmap. So as you can see right here, the correlation matrix basically helps to identify correlations between different features of the dataset, where in this case, the code uses Pearson correlation to measure the correlation between the features. This stuff is basically useful to identify which features are highly correlated, and which can help us in, knowing which features to use for our prediction. I mean, like, this is not really necessary because we're gonna be doing selection later on, but yeah, this is just to know. And finally, we just describe the data frame just to know the state. I mean, like, what's the count, what's the mean, or the standard deviation for us to use later on. Now that we have got that out of the equation, we're gonna test the accuracy of our modeling. So we're trying to model a little bit. First up, we put those into an array of x and y for us to split them into training and testing, just to model our prediction. So as you can see right here, first up, we're importing from the scikit-learn library, and which is the most important is the train test split, because you want to split them into training and testing set. If you scroll down a bit, you can see right here, we're just doing the splitting, where 70% is allocated for the training and 30% for the testing. as you can see right here. We state it right here. And next, we just use the rich classifier function, which is basically like a classification techniques. And yeah, just train the model using the training set we've defined earlier. And finally, we predict the response of the prediction and just print out the performance, the accuracy of the prediction. And as you can see right here, the baseline accuracy is 0.833 yada yada 4. Yeah, so that's pretty much it. I'm gonna pass the feature selection and further prediction improvement onto Afiq Kushairi.
Assalamualaikum warahmatullahi wabarakatuh. So now let's move into our the last part, which is we want to publish our model. Okay, so we are using Python and also Streamlit packages to make the UI. Okay, for example, this is all the user input. That is this is the output lah. Okay, so for example, I want you guys to understand is this. This is the gender variable, and this we use the radio, and then the inputs is 0 and 1. So if you choose 0, then it will assign 0 inside the gender, which is for male. Yeah, yet it also have many others types of input. For example, slider here. So the minimum is 2 and the maximum is 600 for the loan amount, right? So loan amount, how many that we want to have a loan for. Okay, so that's it for the UI. Okay, so the model is now inside our Jupyter notebook, as has been explained by Arif just now. We train the model inside Jupyter notebook. So how do we want to transfer it into our Python file, our interface file? Okay, so we just do the regular machine learning steps. Okay, with the example of RFE, which is the recursive feature elimination. So we are using rich classifier model. So this is our model name, RFE underscore CLF. Okay, and then we do the usual fit the model, and then the accuracy. We export the file. How do we export the file? Using Joblit package. Okay, so how does it work? Is that we take the model, the Joblit package, and then we packet it, and it will become a file. So this is our model, RFECLF, and this is what our file names will be. So it will export like here. This is regular, this is RFE. Okay, mind you that we have many models, so we export many pickle file. PKL is pickle. Okay, so that is how we export and import file lah. Okay. Now for here, okay, we only use 3 feature selection. We only use 3 options. The first one is the baseline accuracy. The second one is feature elimination, which is the RFE. The third one is feature extraction, which is the PCA. So let me explain. For example, how it works. Okay, so no feature selection. The user have already input all the user input, right? So in the Python file, we have the data from the user. For example, this is the function for if the user chooses no feature selection. Okay, this one. This is a crucial step lah. The F prediction. This is where we want to store our user input, but we need to repackage it inside data frame, because just now the model in data frame, right? So we PD the data frame, and then we fill it with our variable just now. See, for example, gender here is the gender from the user here. So all this is stored inside the data frame. Okay. Why do we store it inside the data frame? Because we want the model to recognize it. We cannot just use maybe like array, we cannot. Okay. For example, I got an example. This is the example that I want before I export it. Okay. So this is RFE CLF predict. So we want to predict. So this is the input that we want. I mean, this is just the raw input. Okay. So as you can see here, I print out the columns that RFE selected, which is this 6. So I just just input this raw. I just type it 0 or 1. I mean, like, I know the value lah inside the table. So I just input it 0 1 0. So if it can predict just this one, that means this one we can put it inside a variable, which means that user can determine the value. So it is my thinking based on this. Okay. So next, after we have got it into data frame, then we import it back. Okay. From this one is the Python Jupyter notebook, and then we export it inside here, so it will become a file, and then we import it back into the index.py. Index.py is my UI. So we import it. Now our model RFE underscore pickle is inside the regular CLD model. It is actually a typo. It's supposed to be CLF. Okay. So sorry, I'm in a rush. Maybe like last week, and I am too lazy to, commit it inside the GitHub. Okay. So next, we just use the regular. So this one, this 3 line is actually the same as this one. We want to know the output. So this one, the output is 1, which means that it is they are eligible lah. 1 is eligible, 0 is not eligible. As you can see here, if you input 1, eligible. So for the no feature selection, it will send all the data, all the columns, right? But for feature elimination, RFE, here, let me pick feature elimination. You can see here, we only choose 6 features, which is this one. Where do I get this? Inside the Jupyter notebook here. So, instead of sending all the data, I'm only sending this data. So, because I am not using no feature selection, I'm using RFE, so I only send it as this data, 6. And then the other is just the same. So for PCA model, it's a bit different, okay, because the two are, the PCA model is feature extraction, which means that the data will be jumbled up before it can be fed inside the model. Okay, so this is the problem with feature extraction. Okay, I will explain about the feature selection first, right? You have many columns, and then we train the model based on the column. Okay, right? So when we want to predict, we give value based on the column. Okay, this is straightforward. But for the feature extraction, we have the column, but the column will be jumbled up. It will be like, maybe like we do some operations lah. So the data will be a new data, and it will be unrecognizable. Okay. So let's say I do the same step as RFE and others. Then I export it. And then when we have the user input, how do we want to know what data is what? Do you get me? Okay. So instead, instead of I export the file, the PCA file, I copy paste the coding for the Jupyter notebook inside the Python file. You know that everything that is everything that is processed by Jupyter Notebook can be processed by Python because it's the same language. So, but do you know why do we want to? So why do we use picker file? You know, why we import, export? Why don't we just copy paste all the Jupyter Notebook inside this one, right? Because we want to, preserve memories and also want to make it faster lah, and make the code not too, complicated. So the workaround is that we have the training data, and then we jumble up based on a certain settings, and then we store the settings. Okay, so we do the regular machine learning process. We train the data based on the jumble up data, right? So when we get a new data, the user input, the one array data for the user, we jumble up the user input based on the settings that we saved just now, right? So then it will run smoothly lah, because it is the same setting. Okay. So here I just a bit like just FYI for your information. It it created 5 components. As you can see, PC1, PC5. So for example, PC0, PC0 here. The higher the number is, the more weighted the columns. For example, column 0, PC0, applicant income is the majority of it is applicant incomes. So this is how it works lah. Yes, I think that's it. Okay, so you can maybe play around, right? Here, can play the